This is in high school Algebra 1 lesson on parallel and perpendicular lines. Here we have the symbols that go for them. To say that two lines are parallel, we'll use this marking. It's two usually slashed, usually at an angle, two lines that are, parallel, to illustrate that they're parallel lines. Usually we would put something like, if you had line A and line B, you might say line A is parallel to line B. That's tough, huh? Okay. Sometimes they're written straight up and down. They're going to need to usually be longer than just the letters that you're doing, because otherwise they just look like L's or ones or something like that. Put them pretty close together. That way that'll work. Okay, so a parallel line, that's how we're going to write it. And a perpendicular line, there's the mark right there. Okay, so if we had lines C and D and they were perpendicular, you would say C is perpendicular to D. So that's how we would write it. Okay, parallel and perpendicular lines. Okay, let's learn something about them. That's the symbols. Here, parallel lines have the same slope but a different intercept. Okay, let's think about that. Of course, that makes sense. Duh. Let's think. Parallel line means it's at the same slope. And if another one is at the same slope, oh wait, and if another one's at the same slope, oh look, they're all parallel. Cool, huh? Okay, the same slope makes them parallel. Now they're going to have a different intercept. Now remember, when I just say intercept, I'm meaning y-intercept. There's also an x-intercept, as we've mentioned, but when I just say intercept, I'm meaning y-intercept. And typically, by the way, if it's the x-intercept I'm talking about, I'll usually call it the zero, although both of them have a zero and both of them intercept an axis. The y-intercept we call just intercept. Okay, so what if we have two parallel lines, same slope, different intercepts? So, as an example, you might have two lines that look like this. Oops, that's not very parallel. Pretend. Okay, and so if that were on the coordinate plane, it would look something like this. There's an intercept, there's an intercept, they're parallel. To show that we're parallel, we're going to mark them with the same marking, with an arrow showing it's going the same. Okay, now see this thing's drawn crooked? Okay, the rules are, if it's marked parallel, it's parallel, even if they look crooked. We go with the markings because, like, I was just too sloppy when I drew it. So it also might look something like this. Here's a different one. And so you could have some over here. Doesn't matter which direction or how steep, if they're parallel. Now, if I'm doing this in the same diagram, I don't mark them the same, because that would mean that these were parallel to those. No, they're not. They're not. They're not. They are, however, parallel to each other. So I would mark these different ones with two marks. So two little arrowy things, and two little arrowy things means these two lines are parallel. And one little arrowy thing and one little arrowy thing says these are parallel even though they look crooked. Okay, so parallel lines, same slope, different intercept. Okay, perpendicular lines. Perpendicular lines, the slope is the negative reciprocal. So, for example, if we had a slope equals 3, well, the reciprocal is 1 over 3, and make it negative. Okay? And we would call this, another way to write it is the slope of the perpendicular line. Remember subscripts. This is a subscript. It's a perpendicular sign. That's a subscript. That does not change the value. It's just saying, oh, I got this line as the slope, and I got this line as the slope. And this is the one I'm talking about, the perpendicular one. Okay? We'd do the same thing here. We could say that it's the slope of a parallel one. Okay? So, again, negative reciprocal, that's how we're supposed to say it, but you know, what does that mean? Yeah, it means negative reciprocal, and that means flip and change the sign, right? But officially, we're going to say negative reciprocal. Yeah, negative reciprocal. Okay? So, 3 is the negative reciprocal of negative 1/3. These slopes, if applied to a line, will make perpendicular lines. That'll look something like this. So, if we had a line going like this, let's say that's a slope of -2. I'm just going to say, let's say that's a slope of -2. I just kind of drew it. And then I want a line that's perpendicular to it. It might look like this. Perpendicular, remember, is a box in the corner. And so that one would be a slope of -1/2. Oops, positive 1/2. This one's -2. That's going uphill. Of course, it's positive. Okay, slope of positive 1/2, a slope of -2. Those are negative reciprocals. Okay? So, let's play with this a little bit, make sure we get an idea what we're talking about. Okay, remember parallel lines have the same slope and a different intercept. You know what? If they had the same slope and the same intercept, would they be parallel? Same slope and a different intercept? You know what? They would be the same line. So that would not be as big of an issue. Okay, so I'm going to try this. I'm going to make me a little, and you do this in your cipher. Remember, you're taking notes in your cipher because you'll have a beautiful cipher, but I mainly want you to have a beautiful mind. I want you to know what this stuff is. So if you'll write it down, it will reinforce. So write it down, please, 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 please. Okay, so I'm going to draw, and you just draw 1, 2, some axes. Doesn't have to be perfect. Make them perpendicular. Do that. That's the origin. That's the X. That's the Y. But you already knew that. Okay, let's say we've got a slope and line that is, let's see, I'll say Y equals 1/2 X plus 1. Okay. Y equals 1/2 X plus 1. Okay, that is in slope-intercept form. So the easiest way to grade it from that, autofocus help a little bit. Okay, would be, well, start at the intercept. There's 1, we'll say. And then the slope is going to be, remember, slope is rise over run. And so that would be a slope of 1/2, rise 1, run 2. Okay, rise 1, run 2. Rise 1, run 2. Now, do this more than once, because that way you can figure out if you made a mistake. Rise 1, run 2. Maybe do it backwards. Fall 1, go backwards 2. That way you make sure you've got a good line. You line them up and you draw it. Okay, so there is an approximate Y equals 1/2 X plus 1. Okay, so now I want the parallel line that goes through the point 8, 0. Okay, so I want a parallel line. So now I'm going to want parallel and going through the point 8, 0. Now that's going to be somewhere along in here. Let's say that's 8. Probably isn't if I count it out. Okay, parallel. Okay, this is the slope of the line. Here for our original line, the slope is 1/2. So the slope of the parallel line will be the same thing. So the slope is going to be 1/2. But I want it to go through the point 80. Okay, well, I wonder how I should write that. Let's see, I've got a point and I've got a slope. That sounds familiar. I have a point and a slope. Oh, I should use the point slope form. Aren't mathematicians clever about how they name things? Okay, just a reminder, slope-intercept form is going to be y minus y sub 1 equals m times x minus x sub 1. Okay, we'll substitute that in, and we'll get y minus 0 equals 1/2 of x minus 8. Or when you simplify it, you'll get y equals 1/2 x minus 4. Okay? So now we know it's going to go through this point because we wrote the line so it goes through that point. So we're pretty sure it goes through that point. Is there another point here that's handy? Yes, indeed, there is. We have the intercept, the y-intercept. So we can count down 4. Let's say that's going to be somewhere around in here. Look, we have 2 points. We can draw a line. Remember, 2 points determine the line. As long as you've got 2 points, you're doing good. Ooh, hey, I did that pretty straight. I'm impressed. So there we have the line y equals 1/2 minus 4. Okay, and these are parallel. So I'll just go ahead and mark them as parallel, even though it didn't really matter. But these are parallel. I put the same number of arrow on them. I know they're parallel. Okay, and this was at 1. This was at -4, and this was at 8. Okay, so again, parallel lines, parallel, same slope, different intercept. Look at them. Do they have the same slope? Yeah, they go in the same direction. They got the same slope. Okay, so now let's say I want a perpendicular line, a line that's perpendicular to my original y equals 1/2 x plus 1, except, I want it to go through the point 4, 3. Okay, 4, 3. This one just happens to be on the line. Okay, so 2, 4, 3. That's where I want it to meet it. I want it to meet the line at 4, 3. And I want to know what the equation of that line would be. Okay, perpendicular. Oops, I left out an R. You know what? It's a whole lot easier just to write the symbol. So the perpendicular, remember, is the negative reciprocal, or flip and change the sign. So we want the negative reciprocal of this slope. Flip it and change the sign. And we want it to go through this point. Okay, so the slope of the original was 1/2. The slope of the perpendicular is going to be, flip it, change the sign, or the slope of the perpendicular is -2. Okay, let's see, we got a point, 4, 3, we got a slope, -3, oh yeah, here we go again, use the point slope form. So that'll be y minus 3 equals -2 times x minus 4. Okay. So, usually when we're doing stuff like this, we want the slope-intercept form. Go ahead and put this in slope-intercept form by isolating the y. Remember, that's the characteristic of slope-intercept form is the y is isolated. Okay. Also called function form. Okay. So Something's wrong. Oh, here we go. It's not wrong. I was looking at it wrong. I want perpendicular. Okay, so it's going to go through this point, and it's going to be perpendicular. The slope is going to be -2. So I'm going to start here, and I'm going to go rise over run. The rise is -2. That means I fall 2. Okay. Fall 2, run 1. Okay. Fall 2, run 1. Do it again on top. Now it'll be rise 2, fall back. Remember, one of them's got to be negative for it to be negative over a negative, right? Okay, so what we'll do here then is we will draw our line, and it should look perpendicular. Okay, so I'm going to put a box because it's perpendicular. And what's it supposed? Let's go back and check and see if this makes sense. Okay, it goes to the point 4,3. That's the one I was asked for. I wanted a line that was perpendicular to this line at the point 4,3. Okay, and so here, -2x. Look at the slope of that line. Yeah, it's going downhill. It's negative. Yeah, it's kind of fast. Yeah, that's probably a -2. Plus 11. Okay, the y-intercept B is going to be a plus 11. Okay, that's going to be up here someplace off the chart. Yeah, probably 11. I probably did it right. So again, what do we see? We see that the slope of a parallel line is the same, and they'll have a different intercept. Here's the parallel lines. They have a different intercept. If they had the same intercept, they'd be the same line. Duh. Okay. And here is a perpendicular line going through the point that we want. The slope is the negative reciprocal, which is the right way to say it, but you know the other way is flip it and change the sign, but we're not gonna admit that we said that. Okay. So let's try doing some of these. Okay. I'm going to start with I want to know if these lines are parallel or perpendicular. Okay? And I think I've written it down here, so I think I'll just show you this way. Okay? So I want to know if these are parallel or perpendicular. Okay, a reminder, parallel lines would have the same slope. Perpendicular would be the negative reciprocal, which we're not going to admit to calling flip it or change the sign. A slope-intercept form is the hands down easiest way to figure out the slope. So if you've got some equation that's in a form or in no form, it's just an equation. Isolate the y, combine all your like terms, fix it up pretty, and whatever the coefficient of x is the slope. That's the easiest way to find it. Okay, so let's look at these three lines. And I want to know if any of them are parallel or perpendicular. Okay, well, they're in standard form, and if you used to get real good at it, and I used to be real good at it back when I took, when dirt was young, because we didn't have the other forms and we didn't have calculator. However, I've said that enough, I'm sure. So let's see. Let's change them to slope-intercept form, because that way it'll be easy to see. So here's the slope-intercept form. Okay? I change it into slope-intercept form. I isolate the term with y, and then I isolate y. And once I do that and clean it up, I see that the slope of line A, again, there's m sub A, the slope of line A is 4/3. Here, I take line B, I rearrange it to isolate y, find whatever's stuck with x, and it's negative 3/4. So the slope of line B, m sub b, is negative 3/4. And here's line C. I redo it all, and I find out that the slope is 3/4. Okay, so are any of these the same slope? Well, 4/3, negative 3/4, 3/4. No, they are not the same. So they are not parallel. None of them are parallel. Okay, are any of them perpendicular? Okay, yeah, 4/3, and the negative reciprocal is flipped, and this negative is the sign changed. These are. So I would write it that these lines, since they're negative reciprocals, line A is perpendicular to line B, and none are parallel. Okay? So, I want for you to please do these problems right here. Okay, we just did number 15, so I want you to do 12, 13, and 14. Okay, so pause, do 12, 13, and 14. In your cipher, write it out, not hand scratch, something you can read and that I might be able to read, okay? Yeah, do these, 12, 13, and 14, pause. Okay, once you're done pausing, here's what we get from it. Look through these and make sure you're doing them right. Okay? Now, let's do finding the parallel lines. Okay, slope of the parallel lines. Here we've got some lines that we want to know if they're parallel. We want to find a line that is parallel. This is the process that I just did, but I'm kind of writing it down here with the steps. Maybe that'll help you a little bit. Okay, to find a parallel line, we want to know a line that goes through this point, negative 1, 3, and has the same slope as this line. In other words, it's parallel. I want a parallel line that goes through the point negative 1, 3. How are we going to do it? Well, this is in slope-intercept form. Yay! It's easy to spot the slope. There it is. Duh. There it is. I see it. The slope is 2. So the slope of the parallel line will also be 2, and we want it to go through that point. Oh, wait. Point, slope. Ah, yes. I'm going to use the point slope form and then rearrange it to whichever form you want. If you want it in slope-intercept and point slope form, you're already done. Generally, we're going to want you to put it in slope-intercept form. Okay, that's the one that we'll want you to do. The relationships will be more obvious when it's in slope-intercept form. So for these exercises, please do it that way. Okay, we start with point slope. Substitute it in, get the point slope form. To get the slope-intercept, we isolate y. If we needed standard, we don't particularly this time, but if we did, we'd rearrange. So here I've taken the last one I had and rearranged it into standard. It would also be perfectly okay to go from point slope to rearrange to get standard. Remember, the way you can spot standard easy is that the constant is isolated. Also, please make no fractions or decimals and make the A term positive. That's a little bit more than some of the texts say now, but as I have mentioned, I'm old and we used to have to do it this way. For years I thought you were not going to have to ever do it because you'd have a calculator. But now it's very clear that you're going to have testing, at least for the foreseeable future, without using a calculator. And the reason this form became the standard form is this is the easiest way to do it with the least number of mistakes, because the careless errors will kill you on this. Again, standard needs to be the constant isolated, no fractions or decimal, and the a term, the coefficient of x, as a positive. Okay, I digressed. So we want to find the parallel line. So now what I'd like for you to do, well, here's another one. Here's another example. Okay, let's look at this one. I'll cover this up first. Okay, again. Now this one has the problem, it was not conveniently in slope-intercept form, because you couldn't just say, there it is. Not slope-intercept form, so that's not the slope. Now, I've already seen some of you just say, oh, it's with the x, it must be the slope. Oh, no. If it's not in slope-intercept form, then you can't do that. You got to put it in slope-intercept form, or it doesn't count. Okay, so I want a line parallel to this line, passing through this specific point. There are ways, and if you're one of those that just likes to be really geeky and figure these things out, there are ways to do this and see what the slope is. You got to be careful, though, because you're going to make mistakes if you do it in your head. You got to be real careful. So the most prudent way is to write it down and change it to slope-intercept, at least to some point till you get so you're really good at it, and you're not there yet. Okay, so I isolated the y, and oh, bingo, look, right there, that's the slope. Duh, I see it, it's with the x. That's it, the slope equals 3. Okay. So, now we've got a point and a slope, so we're going to do it point-slope form. And here that is. I've done the same thing again. I start with point-slope. I substitute in the point -10, 0. Get point-slope form. I'm asking you on these to do slope-intercept form. It's just visually better, and yeah, most of the time you're going to have a calculator, and this is going to work with that. I want you to know how to do it the other way, standard, but most of the time you're going to have a calculator, and most of the time you're going to be using slope-intercept. Okay, so there's a slope-intercept form, and here's the standard form. Again, slope-intercept has y isolated, standard has the constant isolated, no fractions or decimals, and the a term, the leading term, is positive. Okay, one thing that's handy about this is here's our original line in slope-intercept form, and here is our other line in slope-intercept form, and you can just tell they have the same slope and a different intercept. It's just really obvious. Okay, I want you to try a few of these. Please work them. We'll be doing these. Okay, now we just did number 3 and number 11. So do the others. Work it out, find it, and find it in slope-intercept form, please. Put it in slope-intercept form. Okay, pause now. Get them done. Write it down in your cipher. And pause, then come back. So here are the answers. Check and see how you're doing. Hopefully you're doing well. Oops. Pause it for a moment so that you can make sure that you check them all. Now we'll look at doing perpendicular lines. Okay, the perpendicular lines, you're going to work the same as you just did the parallel lines. Oops, excuse me. You're going to work them just the same as you just did the parallel lines. You're going to have a point and a slope, except that the slope will now be the negative reciprocal. So here we have, I want to find the equation of a line that goes through this specific point and is perpendicular to this line. Okay, remember the slope is 1. If there's nothing there, it's a 1, a positive 1. And so the negative reciprocal is the slope of the perpendicular line is -1. So put it into point slope form. Isolate the y. Here's point slope. Isolate the y, and it's really simple. That's the equation of the line that goes through it. Now that one was like easy peasy. You work them the same as you worked the parallels. You just use a different slope. So here, practice on them. Practice on these. Okay. And the one I just did is 18. That's the first one. So go ahead and work these. Pause it while you're working. When you get done, unpause. Okay, so here are the answers that you should have gotten, and I hope you did indeed get them. And I hope that you're doing well, and you will seek additional assistance from me if you need more. And Here endeth the lesson.